that is 4 over 3. If it's 4 over 3, that means you like which one more than the other one? CM or S is this one? You give up 4 for 3. That's what it says. That should be 3. That should be 4. It looks backward, but that's what you give up. You give up 4x for 3y. The MRS is less than 1. You like tea more than, that individual likes tea more than coffee. Right? That's what it is. MRS is less than 1. Anyway, weird individual, but that's the individual, right? Okay. That is that. So far we've seen the budget lines are straight. They're not always straight. In fact, often they're not. Several reasons why a budget line must not be straight. And if they're not, then you may get a corner solution. You have to be careful. Budget line get kinked for 3 reasons. Change in the price, free allocation, someone give you something for free. What's the third one? Rationing. Free. So that has 2 of them when I solve it. Let me show you. Suppose the income is 100. The price of X is 1. The price is 1. That's so far what we did. The price is set. No rationing. No free allocation. That's a straight budget line that we already did. For this individual, the budget line is straight line. Right? Let's change it a bit. Suppose the income is still the same, but if you buy 5 units, thereafter the price is 50% off. So the price is 1 up to 5 points. Then it changes to 50 cents. The price becomes, let me put it in a different color. The price becomes 50 cents if X is more than 5. How will the budget line look like? Up to 5 units, you pay $1 each. If you buy 5 units, how much money will be left with? 95 bucks. Up to that point, that's the budget line. What happened thereafter? We'll see. You still have 95 bucks, right? Suppose you want to take it and just buy X with it. How many units you can buy? Suppose you just want to use all your money and buy X. Let's see. You already bought 5 units at $1 each. You're left with 95 bucks. Sorry, 95. Each one costs 50 cents now. That's the maximum X you can buy. How much is that? 195? 195. 195. That is 195. That's your king budget line. So someone who's facing a change in the price will have a king budget line. That's the initial budget line, then kicked out because the price declines. Make sense? The slope here is how much? 1. That's the initial price. What's the slope there? 0.5. The price goes down, right? When the price goes down, the slope changes. The line gets king. Make sense? So a change in price will kink the budget line, right? A reduction will kink it out. Increase will kink it in. Right? Okay. Next one. The same individual now is offered buy 5 units. I'll give you 3 for free. Alright? Then the price becomes what will happen to this? A third one, third case. Up to 5 units, the price is the same, 1. Then we'll give you 3 for free if you buy 5. Thereafter, anything more, the price is 50 cents. How would that budget line look like? Well, let's see. He bought 5 units. He can get 3 for free. So technically it goes to 8. Paying $5. You still have $95. What's the other end of the line now? It goes all the way to how much? 100? 98. Now you get 2 kings. 1 because it became free. Now the slope is 0. It's free. That means it costs you nothing to get it, right? Got king twice because you get it free, then you get it at discounted price. So now you have 2 kings. 1 because it's free, and then it becomes cheap. Right? That is 2 kings incorporated. That's a 2 source of king's demand. Free allocation, change in the price. A free allocation, shift the budget line in a parallel fashion. Buy the amount given for free. A change in the price will twist the budget line. The third one, which is rationing, will have it later. There is nothing outside these 3. There are 3 sources of king's budget line: free allocation, change in the price, rationing. That incorporates 2 of them. We're gonna have the rationing later. Make sense? Okay. Now read this question, see if you can answer it. She buys X and Y. The more X she buys, the lower the price. How do you think the budget line looks like? The price of Y is fixed. But the more X she buys, the lower the price. How do you think the budget line will look like for her? So yeah, this is the setup for her. That's her income. That's the price of Y. That is where she starts from. The question says, the more she buys, the lower the price. How do you think the budget line looks like? Visually, how does it look like? It starts with high slope, because it's expensive to buy X. It goes to become cheaper and cheaper. That's cheaper and cheaper, right? Because sort of it looks like some indifference curve. If you make it continuous change in the price, very high price become cheaper and cheaper to buy. Make sense? You get basically every time you buy, you get a kink. But in a continuous framework, it becomes like complex. Make sense? Okay. Obviously, we don't make that assumption ever. We just have 1 price change, 1 free quantity offered. But if you change the price continuously, then you get continuous change in the slope, which gives you a convexity relation. Make sense? Okay. Next one. I want to go to number 1 corner solution. Let's see. Kai is maximizing her utility. She cannot do any better. She's doing the best she can. So that's given. At the optimal point, MRS is lower than relative price. What do we call this? That's the definition of corner solution. That's the corner solution. That's what the corner solution is defined as. You're doing your best, you cannot satisfy tangent condition. The easiest corner solution is when tangency is not even possible. That happens when you have perfect substitute. Perfect substitute, MRS is constant. How can you make it equal to budget line? Make sense? Say this is the individual. Was it 3? James, the one we had. It was like this. What's the MRS for James? 3 over 4. Make sense? That's the MRS. Suppose James has $100. Suppose the price of X is 1, price of Y is 1. What would he do? The average is 3 over 4. The relative price is 1. What does he do? What would James do? That's the James we had before. That's the utility for him. The MRS is 3 over 4. The relative price is 1. The MRS is less than relative price. What does it mean? He does not like X as much as it costs him to acquire it relative to Y. What should he do? He should buy less X. What's the less X beyond 0? Nothing. That's what he does. He goes all the way to 0. He arrives at Y corner. That's the answer. He will buy no X. He spent all his money on Y. Because he cannot do any worse. Well, he cannot do any better. He doesn't like X, but the minimum he can buy is 0. Make sense? Even at that point, he cannot satisfy the anti condition. So, for James, it would be I spend all my money buying X. Sorry, Y. I spend nothing buying X. The easiest corner solution is FX substitute. If MRS is less than relative price, you just buy Y. If it's more, you just buy X. Right? But you know you get the corner solution because tangency is not possible. Make sense? The MRS is constant. How can you make it equal to the relative price? If I want to graph it, that's the way the graph looks like. That's the bottom line. Right? The slope is 1. That is 1 in the front curve. Is he optimizing? No, if you shift it up. What's the maximum satisfaction he can get? He would be at this corner. Cannot do any better. Pushed up is in the first curve, all the way to the limit. You can't do any better. That's the solution to that, right? If MRS was higher, say it was steeper, it would have gone where? It would have gone all the way to this corner. So depending on MRS, if MRS is less, he just buys Y. If MRS is more, he just buys X. No matter what, you're about the corner. The easiest corner solution is perfect substitute. If tangency is not possible, check MRS, compare it with relative price, less, you arrive at Y. X, or more, you arrive at X. Make sense? Anyway, that is this individual, because the question says MRS is less. But no matter what, perfect substitute always give you corner solution. Cobb-Douglas never give you corner solution unless the bottom line is king. Then they may give you corner solution. And the question does not say bottom line is king. So class number 1, you're not going to get corner solution unless there's problem with the bottom line. Right? Class number 2, perfect substitute always give you corner solution. Okay? Okay. Okay, next one. This is class number 1, Cobb-Douglas. If you read the budget line, there's no kink there. This is basic one. No corner solution is possible. Just use those 2 equations and solve. Make sense? So, if I look at this one, I say this is just 2 equations to solve. Tangency, bottom line. I'm going to do it. I just have to find the MRS. And it's Cobb-Douglas. What's the MRS? Alpha, beta. What is alpha? Alpha is 0.8. Beta is 0.5. That's Y. x. That should be equal to the relative price. What's the relative price? 10, 20. Just remember, this is a common misconception. People think this is MRS. It's not. MRS is this one. That's the slope of the indifference curve. It can be anything. Go from infinite to zero. In equilibrium, it's equal to relative price. This is MRS. That's the slope of the indifference curve. In equilibrium, it must be equal to slope divided by. So solve it now for y. You're going to get y equal to 5, 16. Am I right? Yes, x. Make sense? That's equation number 1. Number 2, dotted line. 10x plus 20y equal to 1,000. Put this one there and solve it. What would be x? What do you get for x? Remember something in the 60. What do you get for x there? Anyone? 61.5. Take this one, plug it there, get y. How much is that one? 19.2. Then I can get the satisfaction he gets, which would be this amount. And that is it. See, there's no, you don't have to think about it, it always works, right? If you have class number 1 functions, straight line, budget line is always the same. Right? Yeah.
Where's the spiral with 16?
That's 5, that's 16. I cross multiply. If you do it differently, just solve it, right? Just put y on the side. But do I do it? I say this goes up, becomes 5, this goes down, becomes 16, x goes there. Right? Okay. I know people do it differently, but this way I say this goes there, this goes there, and this goes there. Anyway. Okay, we arrive at very nice rationing question. This one, been in the midterm, actually was in the final. When I do it, you see this is not very complicated. Let's see how it goes. But the rationing case is a nice case. Let me open a page there. Question for you. What's the name of that utility function? Is it class number 1, 2, 3, or none of them? Is it one of the popular ones? This is CS. A is 10, alpha is 1/3, beta is 1. Okay. Make sense? So it's class number 1. In part A, when there is straight line budget, is no different than Cobb-Douglas. CS does not give you a corner solution. It's a class number 1 complex multi origin, does not give you a case. You can just do it the way we did it. In part B, we introduce kink budget line through rationing. That may give you a corner solution. But part A is like the one we did. So I'm going to start with part A. Just solve it before the rationing. Exactly the way I solved. 5. Just a different utility, we'll get a different MRS. What's the MRS for this function? What was the shortcut for MRS for CS? Don't want to do shortcut? MUX divided by MUY, which you don't want to do. It takes time. Just memorize the shortcut and you have it for these two. For the rest, take derivatives. What is MRS for this function? Yx? What's that s? 1 minus? How much? Alpha, which is in this case 1 over 3. Right? Alpha is the power of x and y. Make sense? So that gives you Yx 2 over 3. The question says the prices are 1, 1. That is the relative price. So I'm going to solve for y. It should be equal to x. Right? And I'm going to apply the bottom line. I'm going to solve it. Okay, the utility function will change, but the process is the same. It just changes. The utility just gives you different MRS. It does not change anything else, right? Make sense? Good. So that is the optimization for the consumer if you ignore the rationing side which comes later. Before rationing, that's what he does. How much satisfaction he gets? Let's calculate that one. This is no rationing case. Satisfaction, which should be this one. I took this, plug it in the utility function. That's the satisfaction the consumer gets at the optimal bundle before rationing arrives. How much is it? I need this number because we need to compare it with rationing, then graph it. How much do you get? Anyone? I need the number. Huh? 504? 504. This individual get 504 U-tile from that bundle. Now the same individual faces a different scenario. The government comes in and says, you cannot consume more than 7,500 units, but we'll give you 50% discount. Right? The price is not 1, it's 0.5. Right? If you have rationing, solve it with a new price, but ignore the rationing. Then if you want to consume more, you're rationed. If you want to consume less, you're not rationed. So you cannot assume, since he's rationed, he's going to consume 7,500. He may want to consume less. So ignore it. If you have rationing case, ignore the limit, solve with the new price, then decide whether the ration is applicable to individual or not. Make sense? Rationing might not be binding. So this is the way I solve it. I ignore this one for the time being. Don't consider it. Redo the same thing. Redo the same thing. The MRS is still the same. This is still the same. The rated price though is not 1,1 now. How much is the rated price? It's 0.51. The price is not the same. So I'm going to apply that one, and I'm going to solve for y. I'm going to get this one. What would be this? That's 1 over 2, that's 2 over 3. I flipped it to get the y. That will be 1 over 2 to the power of 1 over 5. 1.5. How much is that? I need that number. How much is 0.5 to the power of 1.5? 0.5 to the power of 1.5. Should be a small number. 1.5. So that is that. The bottom line is this one now. because the price of X is 50 cents. The price of Y is the same. You still have $32,000. So take this one, plug it there, and solve for X. What do you get? That's 0.5, that's 0.35, that's 0.85. So X should be 32,000 divided by 0.85. How much is that?
3764.7.
37?
3764.7.
Just round it. 37,640? 47. 47. Is that possible? It's not. I cross it out. It's not. There's a ration there.
No, it is 37665, right? 3765.
3765?
Yeah.
3,000?
Yeah, I got it.
How do you get 30,000? That's 32,000 divided by 0.85. That's a really big number.
No, it's 37,600.
37,600?
37,647.
You missed it. You missed a zero there. It's 37,000, not 37,700. It's 32,000 divided by 0.85. It's more than 32,000. You're mixing it up. That's not possible. For this individual, the rationing is binding. That's what we call it, right? You don't know that. Someone might want to consume, someone might not be a big consumer of X, right? Or that individual might not be bonding. You don't know that. You have to solve it. But for this individual was, I'm going to cross this one out and replace it with how much? What the government allowed, the ration. Then I'm going to try find Y. To find Y, this is useless now because tendency doesn't hold anymore. I have to use the budget line. Take this one, put it in the budget line and find Y. Don't use the tangency anymore because it doesn't hold anymore.
We always have to check it.
Yes. You don't know if the ration is binding. You can't assume it. If you think about it, when the government rations stuff, not everyone want to consume more than that ration, right? It's only for them that's binding. You don't know that. Don't put, I've seen people putting this there. That doesn't work anymore. The tangency condition does not hold. In the case of ration applied, you will see that graphic in a bit. Put it in the bottom line. You're going to consume 7,500. Use the budget line to get Y. What would be Y? What would be Y? Anyone? Yep. 32,000 minus half of 7,500. How much is that? 28? 250. So now we have to calculate the satisfaction we get from the rationing scenario. We need it for the next step. How much is that one? That's the rationing satisfaction. How much satisfaction the consumer get from the rationing scenario? Anyone?
226.
How much?
226.
226? That looks too small. Are you sure? That looks way too small. Anyone got the code? Anyone got anything else? I think it's like around 500. 500. It's just rounded. I just want to know which one is bigger, which one is smaller. He prefers no ration. He prefers no ration. Alright, so when you graph it, that's important. He prefers no ration. Okay. So now I have to graph it. Let's see how I graph it. Most people, they can actually do it numerically. They have problem with the graph for some reason. So pay attention, see if it makes sense to you. But the graphing part is the one that, at least that's why most people have an issue with. I graph the no rationing first, that's the easy part. That's the no rationing first. That's that, and it consumes somewhere right in the middle. That's the budget line and the optimal allocation for part A, no rationing part, no rationing case. Alright? Okay. Now I have to graph the rationing one. I'll graph the indifference curve at the end, so I left it for a reason. In the part B, when ration arrives, the price changes. Alright? So graph the line with a price change. First, it looks like this. Right? But not all that budget line is available because ration, cut it off at the ration. And you cut it off at which point? 7500. Eliminate this part. Cross it out. That's not available. You cannot go there. I just put the whole thing because I want to get nice slope, right? That's the way we solved it. We assume all the budget lines is available. We solved it and said that's not possible. We eliminated it. Right? The individual wanted to be somewhere here, somewhere there, right? It wasn't possible. We went to the corner, which is this one. This is no ration. Make sense? So the rationed budget line is cut at the ration. That makes it king. Not all of it is available. Right? Okay. The indifference curve should look like this. That's the indifference curve for no ration. Make sense? The indifference curve for rationing is a corner solution because the actual tangency was not possible. The tangency was there. There was a tangency there. It wasn't possible, right? We chose the second best. The second best is a corner solution. Graph it as such, that's a corner solution. See? The indifference curve cut the budget line. It's not tangent to it. The tangency was there. It's not possible. I crossed this out, I chose the second best. So, if you want to have it properly, the corner solution is not a tangency. It cut the budget line. Make sense? And the indifference curve shouldn't cross. They don't cross. Don't graph it big such that they're crossing, right? Don't make it like this. Don't make it like this. This is like crossing. Don't do it like that. They cross, right? Make it small. That's fine. They don't cross. That's fine, right? The indifference curve shouldn't cross. Corner solution is not a tangency. Cut the budget line. And more is to the right, less is to the left. This is to the right of this one. This is more than this one. Make sense? Just to the last verification. Just to do the last verification. The MRS was this. That was the MRS. What would be the MRS at no rationing optimal solution? I want to get the MRS at this point. Right? Let's see what we get. That was 7,500. What was Y at the optimal scenario? 28,250? Was it? Well, yeah. What did you get there? How much you get? That's Y, that's X, that's the MRS. At this point, how much is it? Not a small number. Much, much bigger than the slope of budget line. How much do you get? 2 point? 4? Yeah, this is much bigger than the slope of budget line. See the budget line? See the budget line is very flat. This is much steeper. He really wants to consume far more X. He just can't do it because of the ratio. There's no tangency there. If you graph it like a tangency, you get reduction. It's not even possible to graph it. If you do graph it as tangency, it looks like they're crossing anyway. But they'll be all kind of mixed up if you don't understand what you're doing. Make sense? Okay. Anyway, that's a nice graph. See if you make sense of it. I put a question from it on the quiz, but not the graphing part. Graph it, help yourself out. I asked you to calculate the numbers, but didn't put the graphing, right? Did not ask you to graph it. But that graph is nice. Make sure you understand why it looks the way it looks. Don't memorize it. Make sense? Okay. Quiz number 1. Quiz number 1. Don't consult with live or dead people. I mean, don't consult with each other.